Hello everyone, this is Carmen Morales speaking from Rome. In this new video on how to use EarthMap, I will present a case study on climate change in Kyrgyzstan. EarthMap is an application that acts as an interface to Google Earth Engine. Its aim is to allow users without knowledge of the JavaScript programming language used to interact with Google Earth Engine to visualize and process some of the most widely used datasets, including climate, vegetation, forestry, burned area, soils, geosocial, land use, land cover classifications, agriculture, and others. In this video, I will show the possibilities that EarthMap can offer a user with a case study in Kyrgyzstan. For this, I will first give some background information about the situation in the project region. Kyrgyzstan is one of the most vulnerable countries to climate change in Central Asia, suffering from drought, land, and mudslides, while flooding events and riverbank erosion are set to increase in frequency and intensity. Forests and pastures are already under stress because of anthropic pressure and are among the most sensitive resources being impacted by climate change. This story shows how EarthMap supported the development of the Kyrgyz Republic Baseline Atlas. The Baseline Atlas of Kyrgyzstan collects information, maps, and statistics on national and subnational resources. It focuses the analysis on 4 regions or districts identified as target areas for a Green Climate Fund project. With the support of EarthMap and some more in-depth analysis, the atlas was finished in 2 weeks by a team of FAO experts. If we want to start working with EarthMap, first of all, we will select an area of interest, which in this case will be Kyrgyzstan. Here on the boundaries, you can select country, regions, or districts, or municipalities. In this case, the area of interest are 4 regions that are located here in the western part of the country: Susak, Oskon, Aktala, and Togustol. I will propose to start the analysis in one of the districts, Susak, and activating the land productivity dynamics layer. Information about this layer can be always accessed. This land productivity dynamics is a map of persistence, decline, stress, stability, and gain of land productivity strictly during the observation period from 2001 to 2018. And land productivity dynamics can indicate that climate change impact in this area will be exacerbated. So we see that in Susak, this district that covers a mountainous region, partly, the decline of productivity is in this mountain region in the district. After activating the NDVI change layer, which can be found under vegetation, NDVI change, we will see, reading the legend, that vegetation intensity has declined in some parts of Susak. The brownish color represents vegetation intensity that is declining, but it declines especially in the mountainous region. So based on the result of this little analysis presented with the land productivity dynamics and the NDVI change, the EarthMap user can already assume the presence of grassland degradation and risk of landslides in the mountainous region of Susak. In order to support the analysis with more data, climatic variables were also assessed. First of all, we could perform some statistics on precipitation variables at the national level. Let's have a look at precipitation data at the national level in Kyrgyzstan. For this, we click the shapefile Kyrgyzstan or the area of interest Kyrgyzstan, select precipitation, and temporal aggregation annual, and process the statistics. When we have the analysis done, we can maximize the chart to see it better, and we will see that the average total annual precipitation in millimeters in Kyrgyzstan has increased in 10% from 401 millimeters in 1981 to 440 millimeters in 2019, in the last 40 years, around 40 years. In order to understand regional differences, the spatial distribution of precipitation anomalies in the whole Kyrgyzstan can be assessed. For this, we can activate the precipitation change layer at the national level to see that in main parts of the Kyrgyz territory, precipitation has increased, but in the target region, in the western mountain region of Kyrgyzstan, precipitation has decreased. This information is from 1981 to 2019. So the same precipitation analysis done at the national level can be applied to the regional level. This can be done activating the districts again, looking for the Susak district that we looked into before, clicking on it. We have still here the metrics at the annual level and process the statistics. Here they were for Kyrgyzstan. Now we will do the same statistics perform the same statistics for Susak. If we maximize the chart, we will see that in Susak, in the last 40 years, the average total annual precipitation in millimeters has decreased around 40%. It's quite a lot. From 537 millimeters in 1981 to 330 millimeters in 2019. It's interesting because the target areas were indicated by the government of Kyrgyzstan as regions with high risk of landslides. But the annual precipitation analysis in Susak shows a scenario of precipitation decrease of 40%. In this case, it is important to look at the monthly precipitation sums. For this, we can process the same information that was processed at the annual level at the monthly level. So if we process the script again, and maximize its chart again, which is representing the monthly precipitation sums, so to say. From the graph, we can observe that this red and orange lines are the deviations. So the negative deviations have been intensified since the 90s. This reflects the loss of total annual precipitation that we saw before, because these statistics are for Susak. And the positive deviations continue to happen in spring and autumn as in the last 40 years. So deviations can be found especially in spring and autumn. demonstrating the presence of erratic rainfalls that can potentially lead to landslides in spring and autumn, where we have the maximum precipitation. Information on precipitation, for example, at the daily basis, is not possible to process with EarthMap. But in case we will have this information, because this analysis was done at the daily basis in the atlas of the Kyrgyzstan Republic, which I mentioned before. In this analysis for the daily precipitation, this showed that heavy rain events increased in number around 4% since the 80s in the 4 target regions. If we want to analyze the local climate, we can also have a look at the temperatures. So if we click again SUSAC and want to process the annual mean temperature, we will have the mean average annual temperature in SUSAC that increased from 4.8 degrees to 5.8 degrees in 2019 and has an overall upward trend. This can affect the water availability, vegetation intensity, and health conditions of grass in the mountain region. We also know that the minimum temperature influences the quality of the grass, especially when arriving to minus 25 degrees outside the winter months. With the information available in the Google Earth Engine repository, but not having the possibility to create the statistics or process the statistics in EarthMap at the daily basis, we created a figure that is in the Kyrgyzstan baseline atlas with the number of days with temperatures of minus 25 degrees outside the winter months. And we will see that this number increased in the target region in the last years. Most likely, this has provoked grassland degradation in the target areas, exacerbating the already existing climate change impacts. EarthMap guided an assessment in which different parameters, land productivity, vegetation intensity, precipitation, and temperature were considered. The maps and statistics supported the government of Kyrgyzstan to identify hazards, anomalies in precipitation and temperature patterns, and sensitivity factors, land productivity dynamics or vegetation intensity, related to climate change impacts such as landslides or decreasing health conditions of grass, which were putting people living in the area and grazing activities in danger. The assessment in EarthMap provided the information to the government of Kyrgyzstan to identify the drivers of these impacts. Bye-bye from Rome, and I hope you liked the video and it helped you to understand how this fantastic tool EarthMap works. Bye-bye.